Just see if I put that in the right thing. I have put in the right thing. Okay, so Happy New Year, heroes and heroines, and welcome to Practising Programming in C, the first edition of 2017. There's a bit of a hang on a second, let me just check that this is actually still coming through. It is still coming through, apparently. Yeah, so I can just hear my laptop sort of, a laptop fan kind of spinning up. So I wasn't sure if the audio was going crazy or what. Yeah, but anyway, before we start, I have a bit of a thing to introduce. And it's actually a Christmas present from Chrono Dragon. A Christmas present in physical form, which he sent with a note, which I will read now. The note says, Matt, because that's my real name. My instructions were given these out, and I already had one. I know you're getting into C programming, so you'll probably find some nasty bugs. Hope this guy can help you out. I know rubber duck dragon debugging always works for me. Happy Christmas, Chrono Dragon. Attached was this little guy here. So this is my debugger. All this time I've spent without a debugger, and Chrono Dragon sent me exactly what I needed. Can I just see if this? Yeah, you can see this guy. There you go. You can see he's got all like the scales on his body and head and all that. Yeah. So this is my rubber duck dragon. To help me out when I find nasty bugs. So thank you very much, Chrono Dragon. I'm sure I'll be a much better programmer now. And I'll just pop him just right down there. Yeah, so there we go. I suppose I might as well start on the show, mightn't I? And yeah, I'm just going to be doing the same old thing again, which is run length encoding. Now I haven't thought about programming since before Christmas, because it's like before Christmas when the last Practising Programming in C stream was. I haven't thought about the algorithm, I haven't thought about any of the stuff that I learned. So the chances are I will probably just hit the same bugs that I was hitting last time. What's this saying up here? Let me just. If you wish women to love you, be original. I know a man who wore fur boots summer and winter, and women fell in love with him. Anton Chekhov. Fur boots. Well, I suppose that's. I didn't get any for Christmas, so. Yeah, I'm out of luck for another year, I suppose. But anyway, have I sorted everything out? I've got an audio coming through, I presume. Yeah, I can hear that. Got audio coming through. Got me rubber duck dragon. The chat's going in. Let me just see if there's anything down there. Nope. What's happening in random? Alright, Delix is up to some cool stuff. Yeah, so might as well open up 4Coder. And I still need to sort out the building the current file thing. Yeah, because I've currently got this thing sim linked to a build.sh file. Look at all this nonsense as well still here. Should probably clean up this whole directory actually at some point. We got a test corpus. Yeah, all this test stuff here. I think it was temp file. Temp file fresh was the big one, I believe. Yeah, that was 1.1 gig. Which we can use that for today. Yeah, and I think what I'll try and do today actually is just try and recreate the same thing that I did last time. So it's going to be a run length encoder that just works on zeros and ones, and it doesn't record whether it's a 0 or 1 as it's going along. It just records the length of the run, and then it toggles between 0 and 1 because it knows. And if I can do that in half an hour, that would be pretty awesome, I think. But the chances of that happening is basically 0. Without further ado then, let's just get on with it. Right. Yeah, yeah, I was taking all stuff. Hello Fiery and Asaf. Cheers. I'm glad somebody does. So in argc, it was if there's like, if the argc is not equal to 3, I believe, printf, I need media things, don't I? Include stdio.h and include stdlib.h because I need to mark usage is going to be equal to, I mean honestly I could actually, this is actually one thing I did remember. It was printing out the actual first arg. So it's going to be that, and then it's going to be, so I'm printing out input file, output file. Yes, yeah, that is correct, I think. And this is going to be args 0, right? And then it's going to return 1. See if this builds. It does build. Wow, that's a pretty good start. So, see about the passing it as the thingamajig. If I go down to like here, and then if I do this, okay. Wait, can't I do this? Can I do that? I can do that, yeah. So then it just like shows the whole path, depending on where you are. Okay. So if it's not, then it'll quit. Otherwise, we continue. And what is this thing doing again? It's a run length encoder. So I'm loading in a file, right? So let's. Oh, I also had the file descriptor thing. I also had this open. I still haven't read it all, but I remember Fiery was mentioning that he doesn't like to use file, I believe. But he prefers to kind of do all this stuff manually. I'm not going to do that now, actually. Yeah, I'm not going to do that now because I'd just like to try and recreate last week's stuff. But this is probably something I will like to do at some point. But for now, I'm going to have file in file is going to be equal to fopen. So fopen is going to be args1, and I'm making it readable, right? And then I want to read all of this into a buffer, and then close the file. Yeah, I mean, there was that other idea of streaming it in, like a kind of a kilobyte at a time or something. But again, I won't try and learn that at the moment. Right, so we're going to have a car in buffer. It's going to be malloc of the... Oh, I need to find out the size, don't I? So it was... I think... Does this only happens here, doesn't it? Hang on a minute, could I just... I wonder if I could do that computation in malloc. Oh no, because I actually need to... Yeah. It was something like... like this, wasn't it? Seek to the end. And then, was it in size is equal to f port of the info. Yeah, this might be complete nonsense actually. FC, so it's okay. There's an offset as well, right? So it does take the stream, it's an offset and a whence, which is that seek end and seek set stuff. I think it's seek end, yeah. And then f tel. It wasn't f port, it was f tel. And that is just takes the stream. And it's a long. Okay. That's kind of interesting actually. I wonder if instead of doing that, I do like ftel. Can I do this? I wonder. And then just fseek back. Can I do this? I wonder. Yeah, right. So, oh yeah, I haven't stored the ftel, have I? That's interesting, actually. Yeah, I suppose I can't actually do that. Because what I was going to do was print f the length, but... Well, I mean, honestly, I could actually do it here, couldn't I? So if it's going to be a long, which I think just counts as one of those, doesn't it? No. Let's just see what this actually does. Oh, I actually need an in file. What was it again? Temp file fresh. Well, they printed out that, so that's kind of nice. Just didn't free the thing. Have I marked it yet? It's in buffer. Why didn't the F sanitizer kill? Oh, the F sanitizer did catch that. Right. Okay, so that seems to be kind of correct. And that number seems to be the same. Yeah, right. That's kind of nice. So basically, I managed to not store the length in a superfluous variable. So we've loaded this into the, but no, I haven't loaded it in. I need to do my fread. So I've found the length. I've malloped the length. Oh, that's the point actually. I need the length again, don't I? Don't I? Beyond Strustrup caused frustration. So it's buffer, right, yeah, so I do need the size, so I might as well compute it then. Because I need it twice. So int in size is going to be probably to store the result of ftel. Yeah, what are you thinking in terms of the freeing it, you mean? I mean, I am actually going to do that now. So, good to see you here, by the way, Chuggy. Hope 2017 is starting off nicely for you. Buffer in file. In file in buffer is what I actually want. Buffer size is the in size. Count is 1. File. And then I can unload the file. To see if it builds. Yeah. So fread all that stuff in. And then that's the end of the file. Right. Happy New Year so far. Awesome. It's good to hear. So this is just loading this stuff into the buffer. Yeah, and I can believe that that happened. Free it. Okay, cool. So we want like pointers here. It's just pointers all the way down. So we've got in pointer. Is equal to in buffer already. Now it's just a case of how this all goes together. So it's not that. Just because a car is already that. I kind of feel like it's that. Yeah, in pointer is equal to in buffer. Let's just print out the first character. So it's going to be in pointer. Okay then. Yeah, this should be correct. First character is apparently a 1. And it is a 1. Right, okay. Okay, so that's kind of correct. So rather than print effing it, I want to say the token is going to be, the token is equal to in pointer. The token, yeah, the token is equal to in pointer plus plus, I think. Right, so it's going to set the token, then it's going to increment the pointer. And then, so we've got the pointer which we're using to iterate through. We've got the buffer, we've got the token. We just need the counter, and that's going to start off as 1. So then I think it's just where I enter the loop. Because we're now at the second character. I want to say, yeah, I am in the loop. And while the buffer, so we haven't got the end of file thing, that's what it is, so we can't use the end of file. I've got the size, so while I can't remember quite how I did this. Oh, it's that, isn't it? Right, so when it's until the in pointer, take away the in buffer, it's while that is less than the in size, I think. Compare. Yeah. Exactly. See, Joggy, we're so in sync. In pointer, while that take away the in buffer is well, that's less than the in size. It might be less than or equal to actually, but whatever. While that, if the token is equal to in pointer, now I'm not sure if this is going to be quite correct, and it's also this, isn't it? Or is it? Because in buffer stays, and that's not the right thing. So in buffer stays the same. In pointer is the thing that goes across. And because I've already incremented it here, I can't increment it here. Ninja Juke, yeah. What's Interbot saying? Wanted so much of the Rust docs cover that. Would that have helped? Wanted so much of the Rust docs cover that. I don't know, mate. Don't know. I've never used Rust, so I'm not sure what the docs are like at all. If the token is equal to the in pointer, then we want to increment the counter. Else we want to say the token is equal to in pointer, counter is equal to 1 again. And we want to put the we want to actually set the token is equal to in pointer. Oh, we need the oh, actually, yeah, we need to be writing it out, don't we? So while we're setting up all this stuff, I might as well set up a new buffer. Yeah. So it's like the encoded buffer. And increment, yeah. Yeah, cheers. Encoded buffer is going to be equal to malloc. And that's like the in size. I was storing the size, wasn't I? Size of bins. In size. In size plus 1 is plus size of int, I believe. What is this? And that's probably not going to be correct. Yeah. Encoded buffer. Gives a bit more size actually here, guys. There we go. It's more like it. And I don't strictly need this actually, so I could just throw that over there. Yeah. Encoded buffer is equal to malloc. So we also want the encoded pointer. Tell you what, enc will do. Enc pointer is going to be equal to the. Oh, actually no. Enc pointer, is that equal to the ink buffer? I suppose it is actually. Ink pointer is equal to ink buffer. Yeah. So ink buffer is just nothing at the moment. So actually ink pointer probably I mean, strictly speaking, we don't really need a pointer until we've moved on to the second thing. Let's do it. Let's keep it. So ink pointer plus plus is going to be equal to token. Interesting. Right. Okay, right. It's probably no, it wasn't that. Okay, I think that's correct. So ink pointer is equal to ink buffer. And then down here, what's the size of int again? Oh, I need to put the size, don't I? Yeah, that's correct. So rather than say that to token, I need to set this to the int size. Right. And it wasn't that, was it? It was like it was set that to that, and then we increment it. It's like ink pointer. It's like plussing. Yeah, right. It was something like this. It was like ink pointer is going to be equal to ink pointer plus size of int. I think. I seem to remember it's something like that. Actually, can we ink pointer? Can I just do that in one? I wonder. I can't remember if I can do that in one. Ink pointer is equal to that plus size of int. This might actually be a bit wrong as well, just generally. Actually, I can I can print it out, can't I? And then hex curse it. Int size plus size of int. Right, okay. Int size. Okay. Gosh, is it that time already? That means I've only got 8 minutes left, I believe. Yeah. Ink point is equal to that. Is that true? Won't that cast in size to car? Oh, will it? Well, I mean, it is an int, isn't it? Well, I mean, not an int, but it's a long. Not sure what the purpose of this is. Okay, so the purpose of this is the trick that Casey did on his stream. It's putting the size of the input file at the start of the start of the encoded file. so that you know when you come to decode that file how much space to allocate for the decoding, basically. Because you don't know how, without going through the whole process of like without going through the whole process of reading the encoded file to know like how many of each digits there are, you don't know how much space to allocate, if that makes sense. So you kind of have to do it, you'd have to do it twice basically. Once to find out the size, and then the second time, did you have to do it twice? It's as an int. If you want to copy that int as it is to the encoded buffer, you want to. Ah, right. Okay. So yeah, that looks a bit more familiar actually. So right. So casting the end pointer to an int. Let's see. We're going to use void for the buffers. You're going to read and write different types from them. Okay, interesting. I haven't tried that before. That's interesting. So I'm casting this guy to an int. I'm putting the int size in. Int, have I done that correctly? No, I haven't. So it's int, just like that. Int size. And then I need to increment it by the size of an int. Or is it the size of a pointer to an int? No. The main difference is the compiler can't implicitly cast anything to void. Okay. Interesting. See if that actually builds. No. Car and that, in pointer, in buffer. Oh, interesting. What line is this on? Line 37. Wow. Point. Second line could just be enc pointer plus equal size of ints. Oh, that's true actually, yeah. Yeah, I think so too. Yeah. Moving past the 4 bytes, use rotary. Yeah, that's correct, yeah. Still have some car style. Oh, so what were you saying? Was it the pointer as well that you need to use void star for the buffers? So do you mean the buffers and the pointers? Like this. Token is equal to in pointer. No, okay. Where are my cars? Cars in pointer. Void. Ah, no, void. Yeah. Just enc pointer, not enc pointer. Okay. You hear the voice, not what it points to. Ah, right. Yeah, okay, got you. Yeah. Still some car star here. Yeah, I mean I do have car star for the pointers. What's this saying? Car star and point star are not pointers to compatible types. Well, buffer. 12 by 12. Yeah, that's correct, yeah. I mean, if I did this. Incomplete. In pointer. Okay. So it now points to the road location, just following. Yeah. Yeah, that's correct. Yeah, that's what I'm after. So yeah, cheers. Car input. Now at the point of the voice, I need to cast them to the right side. That's how I use them. Okay, right. Yeah, which I don't necessarily want, do I? Okay. Okay. Let's continue then. So whenever I use the pointer, how do I go to the arrow? It's there. Go for explicit here what kind of point you want to each step. It's going to be you want to assume a 1 byte point all the time. Yeah, I mean, and also, as I understand it, because the only types that I'm switching between are cars and ints, they are basically the same anyway, aren't they? Yeah. I don't know, dude. I kind of fancy keeping them as cars, actually. Let's just try it. Car. Ink. So that does build. I'm incrementing. No, I'm setting. So ink pointer was a car, and now I'm changing it to. Well, I'm casting it to be an in pointer. Let's just see what this does. Am I freeing? Oh, hang on a minute. Yeah, I'm probably not freeing enough stuff, am I? And I probably haven't got enough memory. Where are my mallocs? So I malloc the ink buffer, right? Just free the ink buffer as well. And I probably will have to close Firefox actually. How much have I got free? I've got. Well, I should have enough free memory. It's possible I don't though. Yeah. I guess. Fair to allocate that much. The reason to cast to an in pointer is that otherwise you'll only copy 1 byte at a time. 1 byte to copy 1 byte in size instead of all 4. The card size is 1. No, right. Okay. The reason to cast to the in. Oh right, yeah, this guy. Yeah. There's a card int. Oh wow, I've got this happening. Yeah. Dimension recordant is the range. Code 8 bits, 1 byte wide, so you can only store numbers from that. And it's 32 bits, so you can store a wider range. Right. Okay. Print that. So what am I actually getting here? Am I getting anything happening? So I'm not seeing anything being printed. Probably not doing this correctly. I'm pretty sure that I loaded the file in. What am I actually doing here? I'm not yeah, I'm not even outputting the blooming encoding yet. Yeah. I mean, it's going to be this loop, isn't it? While in pointer is less than in buffer, take away the in. Well, input for take away in pointer is less than the in files in size. In pointer, am I incorrect in the in pointer? I am. In buffer is still the same. Don't know if this is going to be at all correct. Well, it's less than in size. Yeah, have I alloced enough? Yeah, I haven't I? Allocated that much. I mean, I suppose I could step into it and see what it's actually doing. In pointer plus plus. So sorry, it's actually, yeah, it is the location, because what you were saying, it's like, it's the location, it's not the value at that location, which I want to be setting. Well, in pointer, take away in buffer is less than, tell you what, for the sake of argument, let's just say that. In pointer is less than the in buffer. So with a bit of luck, this is loading it into memory. Ah, right, okay, so it's done like this. Let's just if, well, I mean, it's got to be, well, I suppose it doesn't have to be this while loop. Print that. Oh, it's probably that, isn't it? It'll be that because I've incremented pointer past it. And I didn't build it. That was probably the problem. So I've done all this loop. Yeah, that was the issue. Okay. Now I haven't got the output. So let's just I think I'm just going to write the output and then call it a day. Enc file is going to be equal to f open the args2. Open it as writable. And then I actually want to be flushing the buffer. And I'm also not setting the thing up here. It's got to be the value enc pointer plus plus is going to be equal to counter. Could this possibly be correct? Well, I suppose it could be. File is going to be equal to that. Enc pointer's moved on, and we've still got the start of the enc buffer. So now I can just write to it, can't I? F open, and I want to do the F right. Yeah, I think I do. Don't know. F right is going to be equal to beyond Structure, so it's buffer. Size is the enc file. Sorry, it's the enc pointer. Take away enc buffer. One of them. Enc file. F right, and then F close it. Enc file. So with a bit of luck, this will actually do the stuff, basically. Yeah, could this just be the whole encoder part of it? Oops. So it's tried to write, yeah, okay, so it's written out, so that looks very similar to the last time. So it's written out a 1, sorry, it's written out the size. It's written out 1, and there's going to be 1, 1, and then 4 zeros. So let's just have a look. It looks good. It looks good to interferos, and it must be good. So let's just have a look at the first 12 in the what is it? Temp file fresh. So it's going to be, that's the size. It's going to be a 1. It's 1, 1. Right. So I'm missing something here. That's the size. First thing is a 1. 1, 1. There should be another 1 there. Let's just see. Count is equal to that. Count is equal to what? It's the it's one of the pointers in the wrong place. In pointer is equal to in buffer. Token is equal to in pointer. Hang on a second. Oh no, the toggling thing was for the decoder, wasn't it? Token is equal to in pointer plus plus. Counter is equal to 1. And then we just need to be outputting the counter. Do I need to actually... I probably have to... If token is equal to that, I might actually print the counter to know. I can't print the counter until I know that there are no more of them. Am I printing the token? Yeah, I'm not, am I? I need the enc pointer is equal to enc buffer, and then I need to do, that's that. Okay, yeah, that's all it is. I've lost my place. It was plus equal size of, and then it's here, it's enc pointer. Enc pointer plus plus is going to be equal to the token. That's the issue. So I just run the whole compressor from the whole thing of a gigabyte file. And hope it doesn't crash. And then if you look in hex curse, now I should hopefully see. Yep. So the first character is it's a 31, which is a 1. So that's what I wanted. So it's a 1, then a 0, then a 1, 1, 1, 1. So let's just have a look. It's a 1. There's 1 of them. There's 1 0. There's 4 1s. Yeah. So that's correct. Yeah. So yeah, that's it. End of stream. I wonder if I did anything that was a bit more compact today. Or maybe I was just doing the same stuff last time, but I forgot. Why 31? Because it's 31 in ASCII, basically. Which I don't care about. At the moment, I just... yeah, I just read it as an ASCII character. I mean, that is correct, isn't it? 31 is 1 in ASCII. Let's just check. So the hex value 31. Hex value 31 corresponds to 1. Yeah. So that's why. Yeah, there's a master password. No. Yeah, so not that. Just did all this stuff. Egg buffer, sub buffer. Well, in pointer, take away the in buffer is less than the in size, yeah. So that issue previously was just the printf trying to write over the, well, trying to read from a location it shouldn't have access to. Egg file. Kind of happy actually that I managed to open this file and write to it and close it without any issues. Free this stuff at the end. Oh, that was the thing, wasn't it? I could have I used to be freeing the stuff earlier. Like I'd do this thing up here. Might break if the file has 128 zeros or ones in a row. Oh, okay. Yeah. So, well, yeah. Hex 16. 8 times. Think about it another time. Yeah, I mean, I suppose I could try it. Right. Yeah, let's just try it quickly. I'm not going to debug it, but let's just see what happens. So let's open up in Vim. Temp file fresh. And we want like 128 zeros at the start. Yeah, just see what Vim is up to. So, okay. Could expand it to 250 by using unsigned bytes. That's true, yeah. It's basically zeros between. Some modular arithmetic. That sounds interesting. Modular arithmetic. I mean, come on, Vim. My compressor works quicker than this. I wonder what 4Coder's like actually at opening it up. Oh, interesting. Blimey. So, did that just crash 4Coder? Yeah, it did. Why did that crash 4Coder? Did I just not have enough memory, maybe? Ah, that's unfortunate. I just got no input here. RIP, yeah, absolutely, dude. Oh, is this, hang on a minute. Is this in Vim's window? Yeah, that was in Vim's window. Yeah. Is there a quick way to, like, echo a bunch of the same value into a file? Actually, I suppose what I could do, I could just, like, do... Right. Is that 256? Oh, it's all on one line. Right. So if I just now count the temp and append that to the temp file fresh, that should work, right? And then we try running the RLE on it again. In fact, it might have been better to actually do the other way around, to like append the temp file fresh onto the temp, just so I've got the test data at the start. It just saved me kind of scrolling. Yeah, can I scroll to the end of this? I can, yeah. So that outputted that. Yeah, I mean, this looks suspicious. 0, 0. Let's just try and append them again. So that was a 0. Actually, let's just take away a few. So trust me, that's just taken away like 6 or 8 or something. Let's just append that, and then I'll relay this. How long have we been going? Basically an hour. Unsigned bytes. So now if I hex curse this thing, I'm getting a 0, and 0, 1, and F8. I mean, all these things are actually ints, aren't they? They only store numbers between 0, minus 128 to 127. Oh, I see what you're saying. I think each of these things, right, are hex values. So it's like 2 bytes. Each of these is 2 bytes long. A car is 1. Yeah, I don't know. 31. I think, yeah, I'll have to think about this next time. Each true character in the hex tree is 1 byte. One byte. Take 1 digit of hex represents 4 bits. Yeah. So basically, I see what you're saying, I think. Right, yeah, it's because this is 1 byte. It then jumps over and then does another byte. and that'll only fit like 2 to the 8. Take 1, whatever. I see. But an int is actually 8 bytes or whatever. I see what you're saying. I think. This is why cases are only a maximum length of 2 pairs. Ah, okay. Interesting. And I think I remember him saying, maybe, that it's quite unlikely to have a run that's so long. Each byte lane will only fit 0 to 28, 128 to 127, so you're using one because you're type, which is site. Right, yeah. Gotcha. Well, I'm using int actually. Oh no. You know, for the thingamajig. Because that's the counter, isn't it? The enc pointer. Oh, it's because the enc pointer is a car. Is that right? Yeah, I mean it's actually an int, so strictly speaking I should do that. Each probably really fit cars by type. Because the only car that I'm writing is actually is the token. Category code is written to the buffer, so it's enc pointer is what the type car. Enc pointer is type car. Right, okay. Interesting. Okay, so this is food for thought, food for mulling over. It's mulling wine for mulling over. Yeah. I mean, will it be? I mean, practically speaking, is this a problem that you need to be worried about? I mean, I suppose in some ways it'd just give me good practice. It could give me good practice to like iterate through things at different like granularities or whatever. The line that says pointer to an enc pointer possible sequence count only takes the highest 8 bits of count and discount. Oh right, okay. Interesting. That is interesting. So let's just see. Yeah, actually I can't do that, can I? I was going to say cast this to an int, but then my malloc can be all off. It's a big problem if count is greater than 128, since the rest of the count is discarded when you assign it to that. Yeah. Yeah, it just give me all bogus stuff. Actually, let's just see what happens. And also unsigned. So I'm casting that to an unsigned. And it's not the token actually, it's for the it's actually for the counter. Don't want to be doing it. I think you take the lowest 8 bits of the ints. Right. How do I do this again? It's kind of like that, isn't it? Oh dear. Int. Jesus. What was this before? It was that. So surely I just need to do int that, don't I? Okay. Don't know what I was doing then. Right. So have I built it? I've built it. Try and actually let's just before I do that, let's just see how big this is. So that's 512 meg, yeah, exactly half. So should we think about Indianness? Yeah, what did you say? Oh, the high state bits. Right, yeah. So how big is this now? It's still 512. I'm not incrementing by an int, am I? That's probably gonna be an issue, maybe. Oh dear. Well, this is really gonna probably be wasting a lot of memory since the runs are never gonna be near the maximum size on ints. Okay. Yeah, and I've also killed hex cursor. Dear me, what's happened? Not quite sure why it's not showing up in. I was using no memory. We had a cast, I think it's alright, 4 bytes to the buffer. But the plus will increment the pointer 1 byte along. Yeah, that's kind of what I was thinking actually. So yeah, I think as the staff was saying, you need to be casting it to the correct thing at the right place. I have no idea why hex curse is dead though. What did I just try? Oh, I just tried to open it with nothing. Was it dead then? I don't know. And I need to do it on that. Yeah, I suppose I can't remember what the old stuff was. It kind of looks similar, but I don't know. Yeah. That would add 4, right? Probably would, yeah. Oh. That? I don't know. Let's try it. Insofar as we'd have to test it to be sure. Well. Assignment to cast is illegal. L value, left value cast are not supported. So star, parentheses, int star, egg pointer, plus plus. Well, it seems to be illegal, so I better not do it. Did it actually work, or was that just a warning, or that was an error? Cops are coming. Yeah, I better go. Yeah, better go and blooming hide. Yeah. So thanks very much for watching. Nice that I not dropped no frames. Yeah. Yeah, I will go actually, because it's been over half an hour. And then tomorrow, it looks like you have a header inside the infrastructure and stream events. It'll probably be easy to treat them differently. Only have an int start inside the loop. That's true. Checking the size of the counter. Also have a dip. So I had it inside the stream events. Yeah, well, I've got a head. The insides and yeah, that's correct. Yeah, insides the first and then stream events. It'll probably be easy to treat them differently and only have an int to start inside the loop. Ah, okay. Because I've currently got a car star. I'm currently car starring. Oh, I see what you're saying. So basically, yeah. So I'm always incrementing the right number. Try checking the size of the counter when I detect a switch, and then using the percentage operator to detect how many bytes you need to fill with runs, and padding zeros in between. So if I have 265 ones in a row, the encoded file should say that. Okay. That sounds kind of interesting. Counter. So when I detect a switch, is a zero necessary in that case? Oh, I see what you're saying. So, right. Just going to look at another byte where it sees a count of 255. That's true. So this is a 255. Huh. Okay, so you'd code that in to be, so it automatically sets the next thing to be a 1. This is all, yeah, definitely food for thought. So it's more like to have a number going to 2 rather than number. Yeah. Right. Yeah, I mean, yeah, I mean, what I was thinking of doing was doing the doing the RLE, and then going on to like the Burrows-Wheeler transform. I suppose I'll have to have a think about it as to whether I want to go down the supporting greater than 255 rat hole. Yeah, whether I want to do that or whether I want to go to BWT. I mean, I also do want to do. I want to do LZ actually after doing BWT. So maybe once I get to the LZ, I'll do the 255 thing. Yeah. But I mean, I'll think about it anyway. And I see there's actually activity. Oh, it's jockey. Okay. Do whichever I prefer. All right. But I do need to please my audience as well. My heroic audience. Sitting through my kind of beginning adventures. So it's now been 118, 119 minutes. See, I can't even read times correctly now. Either or, handling the two very useful to you in Jockey's opinion, just to see how edge cases should be handled. Yeah. Yeah. I mean, I suppose I'm not doing any kind of error checking at all here either. You know, like, I mean, I hit the, like, even this thing, like, I'm not checking whether it successfully loads a file. Or, like, whether the input files whatever it wants. Because that'll just do whatever. But, like, I'm not checking whether the input file exists. I'm not checking whether malloc succeeds, this malloc here, or well, both actually. So yeah, maybe I should actually set aside some time to learn about that kind of stuff, like, you know, error checking, edge cases, do error handling, character building. Okay. Then yeah, next time. All right. Okay, so next time that's what I'll do then. I'll do run that encoding, and I probably won't get to the decoder side of it, but I'll just do the same encoder bit and do the error handling. Yeah, that is what I'll do tomorrow. But until then, I will love you and leave you. It's now been 121 minutes almost. Yeah, I love you and leave you with my appreciation for you being around and being heroic and thanking me, helping me through all of this. Yeah, and I'll see you tomorrow. So farewell for now.